So here we have that the torque and the tension is going to equal the torque sub B plus torque sub lowercase t. So we can say that tension force times 40 meters times sine of 70 degrees is going to be equal to the mass sub B times G, so basically the weight times 20 meters times cosine of 30 degrees plus the mass sub T times G times 30 meters, here again times cosine of 30 degrees. So here we can solve for T and say that T is going to be equal to 18,000 times 20 plus 30,000 times 30. And then this would be multiplied by 9.8 cosine of 30 degrees. This entire thing. And then divided by 40 sine of 70 degrees. And we find that the magnitude of the tension is going to be 284,500 newtons. So this would be your answer for part A. For part B, they want us to find the reaction forces. So the sum of forces in the x direction will equal 0, which means that the reaction force in the x direction minus t cosine of 40 degrees, r sub x is going to equal 284,500 times cosine of 40 degrees. And this is equaling 217,940 newtons. Sum of forces in the y is a bit more complicated. We have r sub y plus t sine of 40 degrees, but now we have minus mass sub bg minus mass sub tg. And so we find that r sub y is going to be equal to the sum of the mass times the acceleration due to gravity minus the tension force sine of 40 degrees. And r sub y is going to be equal to 18,000 plus 30,000 times 9.8 minus 284,500 newtons times sine of 40 degrees. And this is equaling 287,527 newtons. So this would be your y component. And then this would be your x component. So x, y. These would be the two final answers for part B. That is the end of the solution. Thank you for watching.